Hello and welcome to this video in which we're going to begin looking at inequalities, something called inequalities, okay? An inequality is just another way of writing a mathematical statement or a sentence that contains a couple symbols. Instead of being equals, we start using symbols of that something is less than, okay, or something is greater than. Okay. Or we say something is less than or equal to. Okay. Or we use greater than or equal to. And the final symbol we use, instead of using equals, we will use the symbol that something is not equal to. Okay. Now you'll notice that I take the less than symbol and the greater symbol that you are already familiar with when we're writing that, 2 is less than 6 or 8 is greater than 2. We use the same symbols, but then we also use that something's less than or equal to. So instead of using the less than sign followed by like an equal sign, we combine them into one symbol where we do the less than symbol and we put this little line underneath that means equal to. Same thing with the greater than. Greater than or equal to is the little line underneath. And if something's not equal to, we start with the equal sign, we put a line through this. Okay? Okay, so a couple things. In general, if something's going to be less than, in a lot of phrases, we will use phrases like less than, fewer than, okay. We will also use for less than or equal to, we'll use at most, meaning that it has to be a value that's less than it. We'll use the word a maximum height, meaning that the height has to be underneath that. We will use the words no more than. Okay. And then for greater than, we're going to use kind of the same sort of terminology. For greater than, we'll use greater than. We'll use the words more than. Okay. We will also use, for greater than or equal to, we'll use no less than. We'll use the words at least. We'll use the words minimum. Okay. So just a couple phrases that will come in handy. Now, what do we do with this? Let's say that there are fewer than 30 students in the class. What that means is that if I want to represent this, the number of students is fewer than or is less than 30. Okay? So this is taking this statement and turning it into an inequality. Now we can also demonstrate this on a graph, and this is what's called a graphing, what's called the solution. This would be considered a solution. Okay. If I wanted to show this graphically, I'm going to show this on a number line. So like I would plot a 30 on the number line, okay, I would have 31, 32, okay, and I would show 29, 28 on the number line, okay. Normally, if something equals 30, I am going to put a circle and I would fill it in. Okay? Since I want to know that what's less than 30, okay, I'm going to kind of take that same idea, okay, of the 30. But what types of numbers would be included? If it's fewer than 30 students, I can have 29 students, 28 students, 27 students. So what begins to happen is I could have any of these numbers of students, okay, although I hopefully would have a whole number of students, okay, up to 30. But it has to be fewer than, so it cannot equal something. So what I show is that something would begin at 30, demonstrated by the circle there, but since it cannot equal 30, since it's less than, I fill it in with an open circle, okay, what's called an open circle. So it's a circle that's not colored in, and then I show the line with the arrow showing that it decreases by that amount. So let's look at another couple examples of graphing. Okay, if I know that x is greater than 5, I'm going to draw the number line. I could have 4, 5, 6, 7, 8, 9. The first thing I need to think about is, well, what numbers are greater than 5? If x is greater than 5, what numbers can I plug in for x, take the place of x? That would be larger than 5. So I think, okay, well, I can have 6, 7, 8, 9. I could have 6.5, okay? So basically, it's going to be the numbers along here. And it's going to keep going in that direction. So I'm going to put the arrow at the end of the line, okay? And I know it's going to, this number is 5, so I'm going to have a circle here, okay? Now the question is, can it equal 5? There is no equal sign. There is no line underneath the inequality. So I'm going to leave that with an open circle. If I was to change this to x is greater than or equal to 5, it would have the same graph, same exact graph. Okay, so I'm going to repeat what I have up above. The only difference is because of this equal sign, I'm going to fill in the circle to show that, yes, 5 is included. 5 is included. I'm going to fill that in. But you will notice, in both these cases, this and this, there's a circle at 5. Whatever x is being related to, you put a circle. If it's greater than or less than, you're going to have an open circle. If it's greater than or equal to or less than or equal to, you're going to shade, okay? If I have x is less than 5, okay. Oops, I need to have 5 in there. Okay. I'm going to still put the open circle on 5 because the 5's here, but the less than means it has to be less than. It's number 0, 1, 2, 3, 4, okay, and it's going to keep going in this direction with the open circle. And then last but not least, x is less than or equal to 5. I'm going to put it on the number line. Same thing, 1, 2, 3, 4. We're going to include 5. We'll go to 6 here. Same thing, circle on 5, arrow shading, showing that it's less than, and I'm going to then fill in the circle here. Okay, fill in that point, that value. Okay, and there you go. That's inequalities in a nutshell for right now.